All right, hello again, pre-calculus folks. Today we're going to talk about compositions of functions. So we've already talked about the basic operations, add, subtract, multiply, and divide. Talked about that yesterday. But there's a fifth operation. It's called compositions. But really, before we get into doing the actual compositions, let's talk about just evaluating function notation and kind of do a quick review of that. So let's talk about this simple function, just f of x equals 3x minus 4. Whenever you see the word evaluate, which is a common thing even on like SAT tests and ACT and stuff like that, it just means we're finding the answer, right? We're plugging in the given value. So for this one, if we want to do f of 3, we're just plugging in the x. We're plugging in 3 anywhere you see the x. So it's going to be 3 times 3 minus 4, which is just 9 minus 4, which would be 5. All there is to it, you plug in negative 4, 3 times negative 4, again, always a good idea to use parentheses, and that's going to be negative 12 minus 4, which is negative 16. We can even plug in different variables. I mean, if we just do f of t, don't overthink this. It's just going to be 3t minus 4, and this is going to be your expression again. Same thing, we can even plug in a more complicated expression like 2p plus 1. In that case, it's going to be 3 parentheses 2p plus 1 minus 4. Again, this whole thing is going in for the x value. In this case, I can clean this up. So I can distribute the 3. So it would be 6p plus 3 minus 4, and then combine your like terms at the end. So your final answer would be 6p minus 1. Okay, now that last one we did is actually a composition, and we'll talk about that more in just a second, but I just want to kind of get you the feel of what it means to evaluate, even if it's not an actual number, if it's an expression instead. So let's go and do the second one here. In fact, if you want to pause the video real fast and kind of go through this on your own, and then we'll go through the answers. Again, whenever we're evaluating, we're just plugging in whatever that value is, whether it's a number or an expression, just plugging it in for all of the x values. So in this case, it's going to be 5 squared minus 6 times 5 plus 8. And again, we can just evaluate all that. That's 25 minus 30 plus 8, which would be 3. That's negative 5 plus 8. So it's going to end up being 3. Same thing for negative 2. Remember, anytime you square a negative, it does come out to be a positive. So that's going to end up being 4 plus 12 plus 8, which in this case would be 24. I can plug in m. Again, that doesn't really change anything except just what the variable is. So this would just be m squared minus 6m plus 8. Nothing to it. This one's a little bit more complicated. So now we got to do the x minus 3 into everywhere there's an x. Okay, so it's going to be x minus 3 quantity squared minus 6 times x minus 3 plus 8. And again, we can clean this up. This would be either a FOIL or box method, whatever you use. So it would be x squared minus 6x plus 9. And then when you distribute here, we have minus 6x plus 18, and then plus 8. And again, just combine your like terms. So you have x squared minus 6x, minus 6x would be minus 12x. And then we have all the constants. 9 plus 18 is 27. 27 plus 8 is 35. And that would be your final answer. Okay, and again, that last one is really a composition. So let's talk about what the actual definition of a composition is. We've seen a couple, but let's kind of see what your problems are going to look like, kind of in real life, as it were. So here's your definition and your notation. Notice the notation kind of throws some folks off sometimes, but don't let it hang you up. If you see f at g of x, that's how that's read. So f at g of x, or we can use it like a little open circle, also means composition. It's the identical meaning, it's just different notations. We can also do g at f of x, so that's kind of doing the backwards way. But the order does matter. And my hint on this is we're always going to work from the inside out. So in other words, this right here, my f of g of x, basically means I'm taking the g and plugging it into f. So it's going to be g into f. And then on the bottom one, the g at f of x, that's going to mean f into g. Okay, so it's always working inside out. Okay, so let's see how a couple of these things work. So here's our two functions, f of x and g of x. We're going to find f at g of x. So again, that means we're going to take g into f. Okay, so we're going to take this whole thing and plug it in where I see x and f. So it's going to be 3 parentheses x squared plus 1 minus 2. And again, we should always clean that up. So we can just distribute the 3. Got the minus 2 out there, and then just combine my terms if there's any. In this case, 3x squared plus 1 would be your final answer. And then for the g at f of x, now we're taking f and plugging it into g. So now we've got taking the whole function f, 3x minus 2, squared, because again, that x is squared in this case, and then we got the plus 1 on the outside. And again, now we just cleaned it up. Full or box method here, 9x squared minus 12x plus 4. And again, I'm doing that in my head, but obviously if you need to work that out on the box method or write it out FOIL, that is certainly okay. I'm just kind of working it out quickly to save time in the video. 9x squared minus 12x plus 5, just combining those last two terms. Okay, and that's really your composition. That's how you do that. Now, if you want to evaluate these things, notice I use my different notation. So f at g at negative 2, well, I've already got the function, right? So now I'm just going to plug in negative 2 into the x. So I got 3 times negative 2 squared plus 1, and just work out what that is. That's 3 times 4, which is 12. 12 plus 1 is 13. Same thing on this one, g at f of 3. That's the same thing as saying g of f of x. So I'm going to take 3 and plug into this whole function here. 9 times 3 squared minus 12 times 3 plus 5. So 3 squared is 9. 9 times 9 is 81. Minus 36 plus 5. And let's see here. That's 81. 5 is 86. Minus 36 is 50. Okay, so that's your composition. I'm going to do a couple more, and then we're going to look at some tables and some graphs also to kind of see different ways we can evaluate these things. Okay, but again, it's the same deal. It's always doing inside out. So either g into f in this case, and again, we have our two functions here, so g into f. So we have 2 parentheses, 5x plus 3. Always use parentheses. And again, and then just clean it up. 10x plus 6 minus 1, so it's going to be 10x plus 5. And then g at f of x, so f into g, so that's going to be 5 times 2x minus 1 plus 3. And then again, clean that up, so we got 10x minus 5 plus 3, 10x minus 2. Notice these are not the same. They are, I mean, they're close, but they're not exactly the same. So that's an important thing to notice. And then again, evaluating, just putting that x value into what we have. So that's f of g of x, putting in the negative 2 here. And in this case, that would be negative 20 plus 5, so negative 15. And g at f of 3, putting in 3, which would be 30 minus 2, which would be 28. And the last one, something kind of interesting happens on the last example. So again, we have our two functions. f at g, so I'm putting g into f. So the square root of x squared minus 5 plus 5. Remember, everything is inside the radical in this case. Now the 5's cancel out, so we just have the square root of x squared, which is just x. That's all that's left over, because again, square root of x squared, they kind of cancel each other out. Let's see what happens on the other end. So if you take f into g, so now we have, remember, always use parentheses. It's x plus 5. And then that whole thing is squared, because I'm putting that whole thing in where x is, minus 5. Same thing happens, though. The square root and the square cancel each other out, so we got x plus 5 minus 5, and then the 5's cancel out, so we have x. Now, something interesting, this is, we'll talk more about this in a couple of days when we do inverses, but this is actually the definition. This is how you show two functions are inverses of each other. Whenever this happens, if the two compositions are equal, then the functions are inverses. But again, we'll talk more about that in a couple of days. Okay, last bit. So sometimes we won't give you an actual function. We won't have you do the algebra to find the function, but sometimes we'll give you a table and have you just evaluate those things. Okay, and again, the key thing here is to work inside out. Okay, so I've got f at g at 0. Okay, so inside g at 0, look at the table. Here's my g. My g at 0 is 9. Okay, so I'm going to write that down. So g at 0 equals 9, just from the table. Now we are doing f at 9, because g at 0 is 9, so I can just pop the 9 in there. F at 9 is negative 1. And that is your answer. So you take the initial input, see what happens on the inside function. You take that answer, and then that becomes your input for the outside function, and then whatever happens there is your final answer. Okay? I got a couple more of those. I'm going to turn my paper off so we don't lose, so we can still see the table up there on top. So now we're going to do the same thing. So f at g of 8, again, work on the inside. G of 8. Look at the table, see what g of 8 is. In this case, it's negative 2. And then we take that negative 2, f at negative 2, go to negative 2 on f, and it is equal to 10. And that is your answer, final answer. Okay? All of these guys work exactly the same way, but again, work on it inside out. So you want to pause the video real fast and see if you can figure these out on your own. Then we'll go through the answers. So again, inside f of 1 is negative 5. And then g at negative 5 will be 1. Next one, g at f of negative 3. F at negative 3 is 0. And then g at 0 is 9. And then lastly, we got one more, g at f of 4. So we got f of 4. F of 4 is 3. And then we see g at 3. Oh, but wait. Notice if we're looking for 3 in the domain of g, it's not there. So that is actually undefined. That's how you spell that. And that will happen sometimes. So if you don't see, once you find that first value and you go to plug it in or look at the table, if you don't see that value, that means it's undefined, and that's all you'd write for your answer. Okay? And we can do the same kind of trick if we don't have a table. We can do the same kind of trick if we have graphs. So here we have a couple graphs, a couple simple graphs of some functions. And we can do the same kind of trick, right? Notice this is F on the left, and this is G on the right. Always work inside out. So again, G at 2. So we go in here, G when X is 2. When X is 2, G is also 2. And then again, we're going to take that and put it into F. So now F at 2 is 0. When X is 2, F is 0. So that's your final answer on that one. Inside out, inside out, inside out. G at 4 is 0. Take that number, put it into F. F at 0. So when X is 0, F is 3. Hopefully you see how this works. Again, we're just going one by one, inside out, inside out. So F of 1. Again, now we're starting with F. So when X is 1, F is 4. And then we're taking that number and putting it into G. So G at 4. When X is 4, G is 0. And the last one, F at 3. When X is 3, F is 1. And then G at 1. When X is 1, G is 3. And that is your compositions. Your homework is going to be the same kind of things, doing some algebra, doing some tables, and then doing some graphs. If you have some questions, you can come to tutoring any morning. Until next time, stay safe.